Assalamualaikum warahmatullahi wabarakatuh. My name is Farhana binti Abdul Majid. My matric number is AN190169. I'm going to present about my bachelor degree project which titled The Performance of Zinc Oxide Clay Liquid for POMSE Treatment via Membrane Photocatalytic Reactor (MPR). I'm going to start my presentation with the introduction outline. This part consists of 4 parts, which are background of study, problem statement, objective, and scope of study. The first one is the background of the study. Palm oil industry is one source of economic and contributes a huge income to the country. With the high demand for this industry, the problem of pollution is also becoming a concern. Palm Oil Mill Secondary Effluent (POMSE) found after the process of secondary biological treatment of POME. POME is the palm oil mill effluent. This effluent needs to be treated before discharge to the environment. It is due to the high level of parameters such as color, biological oxygen demand (BOD), chemical oxygen demand (COD), and turbidity. Nanotechnology is used to treat the wastewater sector. Nanotechnology can assist us in resolving the current issue with the wastewater management. Nano-photocatalysts are extensively utilized in wastewater treatment because it increases the catalyst reactivity by having a higher surface ratio and shape-dependent properties. Photocatalysis is materials that decompose harmful substances in the presence of ultraviolet rays. Next, the problem statement. Malaysia is the world's second largest producer of palm oil, accounting for almost a third of global production. Palm oil is one of Malaysia's main industries and comes out with 2.7% of gross domestic product (GDP). After the palm oil processing process, POMSE will be released, but POMSE does not meet the criteria to be discharged to the environment. Palm oil processing requires the use of a large rate of water. If the demand is higher, then water consumption will be increased, as well as the amount of POMSE. Moreover, the manufacturing of zinc oxide clay in powder form requires oven drying and calcination, which are time-consuming. It is to reduce the photocatalyst production using simple method. There are 3 objectives of this study. The first one is to synthesize zinc oxide clay liquid under different ratios. The second one is to evaluate the performance of zinc oxide clay liquid for POMSE via Membrane Photocatalytic Reactor (MPR). And the last one is to compare the performance of zinc oxide clay liquid with those of zinc oxide clay powder and commercial zinc oxide for POMSE treatment. The scope of the study is to synthesize zinc oxide clay liquid under different ratios, which are 1:3, 1:4, and 1:5. Ratio differences are able to give different performance to the POMSE treatment process. This study will evaluate the performance of zinc oxide clay liquid for POMSE treatment via Membrane Photocatalytic Reactor (MPR). In order to provide the best POMSE treatment, each performance needs to be emphasized properly. Lastly, in this study, the best ratio of the performance of zinc oxide clay liquid will be compared with zinc oxide clay powder and commercial zinc oxide. Next, I'm going to present about the literature review. This is one of the previous research that used photocatalysts to treat wastewater, which is POMSE. In this research, zinc oxide polyethylene glycol ZnO-PEG nanoparticles were synthesized. Before that, I'm going to explain about the zinc oxide nanoparticles. It acts as a photocatalyst with the help of capping agent. Zinc oxide nanoparticles are one of the important metal oxide materials and are widely used in material science due to their unique physical, chemical, and biological properties. At the same time, it is environmentally friendly, inexpensive, and non-toxic. It has been used as a functional advanced material to solve wastewater problems. This research used precipitation method. In recent years, the precipitation method has been widely developed for the preparation of stable zinc oxide nanoparticles. The process involved and time consumption in this research is longer than using zinc oxide clay liquid. The yield precipitate was dried at 100 degrees Celsius in the oven for 1 hour, and the precipitate was calcined in the furnace under 550 degrees Celsius for 3 hours. But if we use zinc oxide clay liquid as a photocatalyst, the time consumption may be decreased. Next, I'm going to explain about the methodology. This flowchart shows the overall flow of the process involved in this study. The first step need to be done is synthesis of zinc oxide clay liquid under different ratios. The next step is the POMSE will be treated via photocatalytic reactor by three different ratios of photocatalysts: zinc oxide clay powder and commercial zinc oxide. After the treating process done, the effluents will be tested the quality of permit. Those parameters are color, BOD, COD, and turbidity. After that, the effluent will be checked if it is complies to the EQA standard. If the effluent passes the criteria, it can be discharged to the environment. If not, the process will be repeated again. This slide shows the details of each method to treat POMSE. The first one is synthesize zinc oxide clay liquid under different ratios via precipitation method. The precipitation method can be defined as the process of turning a liquid into a solid by turning the substance into an insoluble form. But for this study, we stopped the process before reaching the furnace process. It is because this study mainly focused on the liquid state of zinc oxide clay liquid. If the process were settled, the zinc oxide clay liquid will be in the powder state. The process starts by mixing oxalic acid solution and zinc acetate solution together. Stir for 5 minutes at room temperature. The kaolin powder is added and stir it for 12 hours at room temperature, and then zinc oxide clay liquid are formed. The next method is evaluation of zinc oxide clay liquid performance in terms of color, BOD, COD, and turbidity. The color intensity tested by ADMI color scale after treating process using zinc oxide clay liquid. BOD samples are measured using dissolved oxygen DO-meter. COD test conducted using ultraviolet spectrophotometer. Lastly, the turbidity is analyzed using turbidity meter. Next, the method of performance comparison. The differences between zinc oxide clay formations will be identified. Those formations are zinc oxide clay powder, zinc oxide clay liquid, and commercial zinc oxide. The expected result is going to be explained after this. Based on data analysis and outcomes of the past research, zinc oxide nanoparticles were thought to be an effective photocatalyst for treating POMSE. As expected, the production of zinc oxide clay liquid will be simpler than the one that used powder. The percentage of color removed increased, so does the turbidity reduction. This means that as the rate of degradation increases, the POMSE becomes less turbid. POMSE treatment is required to reduce BOD concentrations in order to produce effluents that meets discharge standards. Moreover, the performance of zinc oxide clay liquid for POMSE treatment is comparable with zinc oxide clay powder. That's all from me. Thank you.